Okay, so this problem is a favorite on the FRQ portion of the AP exam. It comes pretty much every single year, and we call these problems rate in and rate out. So this particular question is about the rate at which mail is being received by a post office. So post office receives mail at a rate modeled by this function, measured in mail per hour, and then the processed mail leaves the facility based on this function, also measured in mails per hour. So notice they gave me two rates, the rate that it comes in and the rate at which mail goes out or leaves. So for rate problems, what we should always do first is define an original function. If A of t represents the amount of mail at time t, measured in mail, I guess, measured in mail, then A prime of t will be the rate of change of mail, measured in mail per hour. And that's going to be, so the rate of change of the amount of mail will be the amount that's coming in, which is I of t, minus the amount that's going out, which is O of t. So this is the key step. Define your original function, and then the rate function, which will involve usually a relationship between an entering and a leaving, or an in and an out. Now that we've set up the problem, let's start A. So it says find the interval of time over which the mail at the post office is increasing. All right, let's see. If I want to know where the amount of mail is increasing, then I want to know where. So translate. A of t is increasing. Well, that's going to happen where A prime of t is greater than 0. So we can set A prime of t greater than 0 by also thinking of it in terms of I of t minus O of t should be greater than 0. That simply means that if I see how much mail is coming in, I subtract the amount of mail that's leaving. If I end up with a positive number, it means that I have more mail coming in than's going out, and the total amount is increasing. So let's set that up. Well, I of t is t plus 1. Okay, let's see. I'll do my work here. Okay, so this is for part A. So I of t minus O of t, I want to see where that's greater than 0. So I of t is t plus 1. I want to subtract from that 2 root t plus 1 and set that greater than or equal to 0. So the way to find the roots here is for now, let's just set it equal to 0, and then once we find the roots, we'll use a number line to see where it's positive. So to solve this and find the roots, I am going to keep my radical on the left and then move these guys to the right side. So that's the algebra that we'll do. So I have negative 2 root t plus 1 equals negative t minus 1. Now I can square both sides. So I'll square the left side and I'll square the right side. On the left, negative 2 squared becomes 4, and root t plus 1 squared becomes just t plus 1. Equals, over here I have a binomial squared, so we'll square the first term. We'll do this times 2. So negative t times negative 1 is positive t, times 2 will be plus 2t. And then a positive 1 at the end. Now we're going to continue solving for t. Notice that our function has changed into a quadratic, so we'll solve by factoring as normal. Move everything to the same side, set it equal to 0. Great, so I can see that my roots are t minus 3 and t plus 1. Therefore, at t equals 3 and at t equals negative 1, the rate of change is 0. So that means that the incoming and the outgoing mail equal each other. So at those moments, the amount of mail that I have is staying the same. But negative 1 doesn't make sense. We don't have negative times. coming back, we want to know where the amount of mail is increasing, so where a prime of t is greater than 0. Well, a prime of t is greater than 0 from t equals 3 onwards. So our final answer will be amount of mail is increasing from 3 till infinity, or actually, they say here only for 0 to 8, so from 3 to 8 then. And our explanation is, since, now this part is key, you've got to make a relationship between your amount, your original function, and then your I and your O. So since a prime of t, which is I of t minus O of t, is greater than 0. So the rate of change of the amount of mail is positive, therefore the amount of mail is increasing. Awesome. Let's go to part B. Is the amount of mail increasing or decreasing at time 3? So if I want to know if it's increasing or decreasing, I need to deal with the derivative, and I specifically want at time 3, so I'll evaluate a prime of 3. Well, a prime, right here, we defined it as incoming minus outgoing. So we're going to do I of 3 minus O of 3, and we'll just plug it right in. I of 3, so I'm looking up here, is 3 plus 1, which is 4, minus. Now O of 3, I'm looking here, is going to be the square root of 3 plus 1. So the square root of 4, which is 2, times 2, which is 4. Interesting. So at time 3, the amount of mail is not increasing or decreasing, since this doesn't have a sign. It is just constant. So our explanation is neither. At t equals 3, the amount of mail, A of t, is not changing, since a prime of 3 equals 0. Oh, whoops. Since a prime of 3, which is I of 3 minus O of 3, since that's equal to 0. Great. Part C. So we're interested when we have the highest amount of mail from 0 to 8. So this is an absolute max problem. Again, anytime you have a endpoints like this, you're looking for an absolute max. So if we want the absolute max of the amount of mail, we want the absolute max of A of t. So we should consider two things, the endpoints and the critical points of the A of t, the thing that we are looking for the max of. So the endpoints are definitely 0 and 8. A critical point is defined as where the derivative equals 0. So for the critical points, we'll set a prime of t equal to 0. And hey, we actually did that work earlier right here. So remember a prime of t, which is I minus O. We set it equal to 0 in this step, and we found that the time where it equaled 0, so our root, was 3. So we don't need to do any more work there. We can just say that the critical point is t equals 3. That's our endpoint. Now we just need to evaluate A of t at all of these points. So we can see at which point the amount of mail is at the max, and then compare the highest amount. But notice we don't know the A function. We made that up. All we know is the rate. So we're not going to just go and plug it into the rate, because that would be wrong. We would have to plug it into A. Since we don't have it, let's reread the instructions. Oh, it just says what values of t should be considered. So we've already answered our question. We should just consider these values. So consider t equals 0 and 8. Our explanation is they're the endpoints. And consider t equals 3, and our explanation is this is the critical point where a prime of t equals 0. And we're done. If we knew what a of t actually was, then we would go and plug it in. Okay, part D says, there's a time t when the amount of mail at the office is decreasing at a rate of 1 per hour. So the amount of male is decreasing. That means a prime of t, we're dealing with a derivative, so rate of change, and is decreasing at a rate of 1 per hour, so it'll be -1. Oh, this is pretty straightforward. All we have to do is set a prime of t equal to -1. And remember, a prime of t is I of t minus O of t, as we defined up here. And I of t is t plus 1. So we're going to set t plus 1 minus, and O of t was 2 root t plus 1 as well. So that equal to -1. Okay, I'm going to move this, make some room. Okay, so I was about to solve this problem, in which case we would like move these over to the other side and square both sides like we did before. But I just realized it's so important to read the question because this one says, just write the equation, do not solve. So we're done. This is our equation. It says, find I of 4 minus O of 4 and interpret in the context of the problem. Okay, if you have set up your initial question, then this is very easy. I of t minus O of t, the interpretation is right here. It's the rate of change of male. The rate of change of the amount of male. So that means that I of 4 minus O of 4 at t equals 4, and that's it. It says specify units, so then since this is a rate that we're dealing with, it would be male per hour.